Okay, so here we have y prime plus 3y equal e to the negative 2t, where the condition is y of 0 equal 2. The y prime, if you look on your formula sheet, y prime is the same thing as s fs minus y0. And then y, the Laplace transform of y is fs. And the Laplace transform of e to the negative 2t is 1 over s plus 2. Now, what we do now, we group the SFS and the 3FS together. So the S plus 3 is coming from this S plus 3, and this should be in a bracket. So let me just draw a bracket. So that's the bracket. So we group the S plus 3, and this is the FS that's coming from here. You can put the extra step if you want. Now, y0, we know it's 2. So if you replace this with 2, you'd have a negative 2. And if we carry it over the equal sign, that's why I have this plus 2, right? Now, the next step, I am going to put this, so let's take this off. I'm going to put this over 1. There's a lot of things happening here, guys. A lot of things. So you find the LCM of this. So LCM of s plus 2 and 1 would be s plus 2. And then now you say s plus 2 into all of this, give you s plus 2. And sorry, that's a mistake. S plus 2 into all of what we have here. So forget about, we put a red marker here. So forget about this. This is not here. So the LCM s plus 2 and 1 is s plus 2. Then I say s plus 2 into s plus 2 goes 1 times. So 1 times this one that we have in the numerator gives you just 1. So I can put a 1 here. And then you have 1 into s plus 2, give you s plus 2. So you have s plus 2 times 2. So 2 times s give you 2s, and 2 times 2 gives you 4, right? So the 4 can't draw. Let us, give you 4. So this 4 and this one, remember this one that I have? Give you the 5 that I have here in black. So that's why I have 2s plus 5. Now, this s plus 3 is coming from here where I divide both sides by s. So this s plus 3, I just bring it over and it goes in the denominator at all times. Whatever you have beside fs, it is going to go down at the denominator. So that's why we have s plus 2 here times s plus 3. Now, we are going to rewrite this 2s plus 5 over s plus 2 and s plus 3 using partial fractions. So you have a over s plus 2 plus b over s minus s plus 3. The LCM, I didn't want to write it because you know the LCM, what the LCM would be. Like everybody knows, the LCM would be s plus 2. So you'd have one bracket here and you have another bracket here. And then you'd say a times this s plus 3 that we have here. That's why I have it here. And then b times the s plus 2 here. This 2s plus 5 is coming from what we have originally from the top right here that I'm circling. And then you start your trial and error. So the trial and error is that when s equals -3 and you put it here, it becomes 0. -3 here, so -6 plus 5, that's why I have a -1. And -3 plus 2, you have a -1, so that's negative b. And then you divide both sides by -1, so you have 1. Same thing here, when s equals -2, this is gone, so you have -2 times 2, that's -4 plus 5, that's 1, and -2 plus 3, that's 1, so that's why a equals 1. So this is 1 over s plus 2, and that's a. This a, you replace with 1. This b, you replace with 1. And then you find the inverse, so this would be e to the -2t and e to the -3t. And you can always look back on it. H of t minus c is an exponential to the raised to the power minus sc, or some persons have cs, while the s here coming from 1 over s, so we know the Laplace transform of 1 is 1 over s. So really and truly, it is coming from second shift, where we know the Laplace transform of ht minus c is e to the minus sc, and we find the transform of the f function. Here we have some examples. Here you have the Laplace transform of ht minus 3 sine t minus 3. If you realize, for you to know it's second shift, you have to be seeing t being subtracted or added by the same value. Once it's looking like this, we know it is a second shift function. To find the Laplace transform of ht minus 3, c is 3, so that is why we have e to the -3s. Let me see if I can zoom in. This is better. So here we have c is 3, and here we rewrite it as sine t. That is like the original function, and we know that the transform of sine t is 1 over s squared plus 1. If you look at this second function, then you have to be seeing t being subtracted by the same number, added by the same number, for it to be second shift. The one that has the h becomes e to the -2s, while this part, you look for the original function. So it's like you forget about the 2. So I can just forget about this. So if I remove this, you realize now I have t to the 3. So that's why I have t to the 3. That's the original function. That's where it's coming from. And the transform of this now, if you look back on your formula sheet, is 3 factorial. 3 factorial is 6. And add 1 to the 3, that's why we have s to the 4. We go on to the next one again, both of them, t's being subtracted by 5, so we know it's second shift. The one with the h becomes e to the -5. So c is basically 5. And again, if I take off this, the original is what? E to the t. So that's why I have e to the t here. And the transform of this is 1 over s minus 1. Now, if look at this, this is a step function, and a step function can become a unit function, can become a second shift function, as you see. So we have this 4, that's the 4 here, and then now we rewrite this in terms of h. So the first part is h t minus 0, which is the same as ht, and then this is ht minus this 2. Then here we have 2, well, I didn't write that part, it would be 2t minus 3, and then you'd have ht minus 2. But whenever you have a t function in this piecewise function, you have to put a t minus. So you just add it in. So that's what we do, plug it in. So when I substitute t minus 2 here, if you expand this part, you get 2t minus 4. Now I have a plus 1 because when I add the 1, I get back the negative 3 that's here. So this that I have here is the same thing as 2t minus 3, but we have to, once you're seeing a t, and one of these have a t, we have to rewrite it in terms of what's here. Now expanding, ht minus 2 times this gives you 2t minus 2 ht minus 2 plus ht minus 2 times 1 gives you this. Now, if you look at this, you have 4ht. Nothing else is added, so we can leave this alone. But these two, they're basically the same. So minus 4 plus 1 gives you negative 3. And then here, nothing can be added to this, so we'll leave it alone. So applying what we learned, this is e to the 0. So nothing happens here. The transform of 4 is basically 4 times 1. And we know 1 is 1 over s. So that's why this is 4 over s. 3, you're about the 3. And this is like 3 times 1. So the 3 is here, and the transform of 1 will become 1 over s. The 2 goes where e. Can remember the h. Once you say h, it's going to be e to the negative. What's the value of c here? 2s. Same thing here. ht minus 2 become e to the negative. This 2, then s. Now, t minus 2, remember I said when you're finding the transform, you forget about the 2 that's here. There's a transform of t, and a transform of t, you know it's what? It's 1 factorial over s to the 1 plus 1. So that's why I have s squared.